We've already taken the first step in bringing our interpreter down to the level of abstraction of the machine. And that first step was to get rid of the symbolic notion of variables at runtime and replace it with just numbers that are offsets into the environment. So that's step one already done. Step two is also something we've already done, though not with our current interpreter. We got rid of our reliance on Plait's implementation of continuations, that is, Plait's ability to call a function and then return to where the function was called. And we did that by changing our interp into interp plus continue with continuation records. So here is our interpreter before we do that. This is the one that has exp but expds, that is, we parse and then compile, and then we interp. This interpreter has those recursive calls where we're relying on Plait. And we know how to get rid of these nested recursive calls. We, in addition to exp and xp, need to introduce a continuation data type with variants like done k, add second k, and so on, and it goes the same as it did before. The interpreter looks the same. The only difference is that where we used to have IDE, we now have @d, and so instead of lookup, we're using listref. That just eliminated one of the recursive functions we were a little worried about before, but no need to worry about now. Now, even though we're not relying on recursive calls, nested recursive calls anymore, we are still relying on Plait's ability to call functions. If you're at the machine level abstraction, you don't get function calls in that sense. All you get is go to. You can just jump to some other piece of code. And we also have some registers that we can put values in. So that's what we're going to do next. We're going to change our interpreter. So instead of relying on function calls like this, where we interp with 3 arguments here, we're going to change it to jump to interp. But before you jump to interp, set a couple of registers. We're going to pass our arguments explicitly in. I say registers, I just mean some global variables at the Plait level, but they simulate machine registers. So we're going to have a handful of registers like xreg and kreg, and the way we pass the argument L to interp is we put L in the X register before we jump. And similarly, we put this new continuation here into the K register before we jump. Notice we're not setting the environment register. In general, we would do that, but in this case, the environment stays the same, and so we don't modify the register. When we make that change in our interpreter, it looks like this. So we still have exp, and we have xd, and we still have continuation records. But when we go past compile down to interp, then we see that we have interp with 0 argument. So this interp corresponds to a location in memory that we can just jump to run the code. And we have these registers, xreg and mvreg, and where we used to do a type case on the argument to interp, we do a type case on the register xreg instead. And when we find a number, then we set the value register to be the number, and we jump to continue. When we have a plus, then we set the expression register to the left-hand side, because we wanted to do an interp of the left. We wanted to extend the continuation in that recursive call, so we do that by setting the K register. The environment register stays the same, and then we jump back around to interp with this call right here. And so on. You see, lambda set the value register to a closure and then continues. For continue, which is relying on a couple of more registers, the K register and the V register, it does a typed case on the K register. And then in add second K, for example, then we extract that right-hand expression out, put it in the expression register, set the environment register, set the K register now to have do add K, and jump back to interp. Now this still looks like a function call, this last call to interp, but we could translate this code fairly directly to machine code that just involves a jump and simulating the machine at that level. It's what's important right now.